If we look at this, we find that the two output stages, the left and right channel audio amps, look practically identical. And they are very, very similar. I'm going to explain to you how they work, and then I will show you where they differ. So first of all, let's have a look at the power supply section. And the power supply section, we've checked and seen that this works. The voltage comes in through the fuse to the 220 over there, goes into 220, and we've got that AC voltage out through the bridge rectifier, the Selenium rectifier, and it comes through this first filter cap, a low pass filter effectively here with this resistor and another filter cap, another 50 microfarad, and we have our first B+ that is used in the amp. Now this one goes to the center taps of the two transformers, as is to be expected. That's that one that comes in there. It goes into there. It goes further up here and into there. So we've got the two center taps of the output transformer being fed by B+. The only other offshoot from this line is this resistor over here, there to there. Now that's a 700 ohm resistor, and we find it meeting a filter cap over here of 100 microfarads. So this is the second B+ filtered with this 100 microfarad filter cap, and it goes to the two grids, screen grid of that one there, or rather the four screen grids, because you've got two pentodes on each channel. So that one over there, that one over there, that one there, and that one there. It then goes off from this point, so filtered B+, to this point here, which is a 27K resistor, and this feeds this line over here, which is again filtered with this smaller filter cap. This line feeds the anode of this tube, or this triode, of that triode, of this triode, and nothing else. The remainder of the radio takes its supply from that filter cap, the 100 microfarad filter cap over there, and it goes in through the top somewhere else. We'll worry about that later. So down here we have exactly the same thing. We've got this filtered value here through another 27K resistor, feeding this anode of this triode, feeding that anode, and feeding that anode, and filtered by its own small filter capacitor. The power supply then for the 2 amps is identical and independent from this point onwards, and therefore they do not interact with each other when it comes to the preamp and the phase inverter sections over here. So the next stage is to see how each of these channels work. I'll go through one of them, I'll work backwards, and I will stop where they differ. So here we have one channel of the power amp. As we've seen, we've got the two anodes or plates of the pentode, the output pentodes, feeding the two sides of the output transformer in a push-pull arrangement. This is the two pentodes in one tube, the ELL80. Effectively, it's a dual EL84 in one package. It is cathode biased. There's the cathode, pin 7. That's pin 7 as well. It has a cathode resistor of 200 ohms, creating the cathode bias voltage. It has a cathode bypass capacitor of 100 microfarads, filtering and bypassing the cathode bias. The two plates, or the two grids rather, of this tube are pin 6 and pin 2. They are both fed via grid stoppers of 3.9K, those two over there, there and there. They both have grid leak resistors of 820K to ground, there and there. And then they're both fed by these coupling capacitors of 10 nanofarads. Because this radio is bass heavy, I may have to reduce that, because the bass response at least the base signal coming through to this section here to drive the two power stages, is actually controlled or affected by the size of that capacitor. The higher the capacitor, the more bass you get through. But anyway, these two sides are fed with inverted signals, the same signal inverted, so you can get the push-pull effect, by this triode acting as a, I believe the term is cathodine inverter. It effectively receives a signal in here at the grid. There's its effective grid leakage, 1 meg, that one there. There's a 47K, there's a 47K, and what this does is it produces an amplified version of the signal at pin 6 on 1 and on this point here, but reversed. Effectively, that is the inverse of that one, and that is actually in phase with that one. So these two are out of phase. The same signal goes through this cap as that one, but in reverse to affect the push-pull system. Then we have this coupling capacitor, which comes from the previous section. And the previous section is nothing more than just an amplifier stage with half of the ECC83, which is the same as 12AX7. It's cathode biased with this 1.5K resistor here. It is actually fed negative feedback through this resistor from the transformer. So that resistor comes back here, there, there. That's the output of the output transformer. So we have cathode biased. There's the plate. It produces the amplified signal of amplified from 2. So the grid is 2 on this triode, and it comes out of pin 1 amplified. It has a grid leak of 1.8 meg. It has another coupling cap from the previous section here, 10 nanofarads as well. This would also affect the frequency response. The lower it is, the less bass you'd get. The higher it is, the more bass you'd get. Then we have this whole system here. Now, what this is, if we look at the previous stage, we have another triode here, which is biased in practically the same way as this one here. So this one here is the first triode in that tube, and this is the second triode in the tube. The triodes are identical, or should be in one tube, and these two are both voltage amplifiers. And we have between them a tone stack. I believe this is pretty close to the Baxendall or the James tone stack used in guitar amps and in hi-fi amps. So this is pretty innovative in itself, because in 1963, I don't believe these tone stacks were very much used in radios at all. You'd always have some more complicated system. This is actually a pretty simple system. It receives a signal through this coupling capacitor. That comes in here. It gets toned or tone controlled, and then from this point here it goes out there, and it's the input of the next stage, which then brings the voltage up again, amplifies it again to feed it into this phase inverter. Now we find the first switching systems over here, F4 and F5, and on the other channel we have a similar setup. It's exactly the same, and what this F4 and F5 does is it bypasses, when you connect it, when you short it, close it, it bypasses this 1N capacitor. Now, when you're bypassing a capacitor, you're allowing more bass through. So I think this is probably, and it is, we'll check it on the rest of the schematic, this is the speech button. So when you activate speech button, it either makes or breaks this point here, which takes this capacitor out of the circuit and affects the tone in that way. So you'll either have more highs or less highs. You effectively end up with a jump in the tone shift, a tone shift in the frequency range, so you get more highs, less lows, which is what you want for speech signals. Say AM radio, shortwave radio, long-wave radio, you may activate the speech signal to get a clearer signal coming through. So speech, that's out of the way. That explains one of the buttons that we had. When we go a bit further back, we look at the input to this triode. We have grid leak of 1.8 meg, and then we have the signal coming back here, or rather it comes from here, from here, from here, from here, and it meets this switching setup. Now this is a coupling capacitor of 10 nanofarads, and through the switch setup, on the other side of the switch setup, at least on this side, we have the wiper of the volume pot. Now this is where we'd expect it to be connected to anyway. You take the wiper of the volume pot and you feed that amplification stage through a coupling capacitor. Very simple, very straightforward. However, we have this mess up here, which we'll have to just look a bit further and see why that's there. On the other channel, if I take it from this step and go straight up to the other channel, what we see is precisely the same thing up to this point, and then it is connected to the wiper of the volume control through this coupling capacitor. There is no switching between these two. So something obviously happens that can separate the 2 amps at this point for some reason, and we will see why in a minute. Just looking at the volume pot, the same occurs on both channels. You have the signal coming in through this 10 nanofarad capacitor into the top of the volume pot. The bottom of the volume pot is grounded, so you have a potential divider which then feeds the input of that tube. What you have here are 2 loudness shaping circuits. They're both in series with 10 nanofarad capacitors, so this is obviously used for low volume loudness control, loudness tonal adjustment, and this is in fact a very simple way of doing what some of the other tube radios that I've seen achieves. They have some very, very complicated circuits at this point, mixed with this section of the circuit. It's all in one around the volume pot, and it gets very, very complicated. This is a very neat system, and I like it. It's a lot simpler, it's easier to understand, and as soon as we get through all this switching arrangements that we have on both channels, there's the other one. As soon as we get through this hurdle and understand what the switching does, we will see that this system is actually a very clean and optimized, in fact a very modern way of doing all this stage of the circuitry. Coming back to this tone stack for a minute, it is indeed a version of the Baxendall tone stack, and this section here is the bass, and that one there is the treble. And it even follows the rule of 10 to 1 in terms of capacitor values. This capacitor is 300 puff, this capacitor is 3.3 N, so 3300 puff, and that is generally what you have in a typical Baxendall stack of 1 to 10. The same applies here. This is 2 nanofarads, this is 20 nanofarads, again 1 to 10. And what normally happens with the Baxendall is that this bass output signal through a resistor is connected directly to that point there, to the wiper of the treble, which then goes off to the amplification. And if we look at this here, with the speech not activated, so in its rest position, this is shorted. And I'll show you the switching in a minute. So effectively, when the speech is not activated, that's precisely what we have. This wiper is connected to that wiper through one resistor down here. And then that signal goes off to the amplification. When you activate the speech button, it breaks that connection. So that connection there is broken. And what you then have is your bass signal, to get to the joint signal, goes through a 1 nanofarad resistor, which reduces the bass. So any capacitor, not resistor, I beg your pardon, capacitor. So any capacitance in series here will reduce the bass. The lower this value, the greater the effect of that speech activation will be. So if I made this 0.1N instead of 1N, when I push the speech button, my bass would drop dramatically. As it is, it's dropping only slightly, so the speech effect is not that dramatic. But that's how it works, basically. The way the buttons work, it's actually quite simple. They've drawn us a layout, a wiring diagram of these push buttons, and they are labeled from B to X on the bottom and 1 to 9 on the left. And so when we're looking at that F, 4 and 5, for example, here it is here. There's F, there's 4, there's 5. It's shown as normally closed. And that means that that is the position it's in when the button is not depressed. So we have normally closed connection there. And F8 and 9, normally closed, that's the speech activation for the other channel. Now, I'm going to go through the circuit describing these, and I will label each switch and show the normally closed position there based on this diagram here. There's one thing here which is different. This PH2 is not phono 2, it's actually stereo. So we have aus for off, S for speech, out for automatic, that's the automatic fine-tuning. We have the stereo button here, phono, then long wave, external antenna, medium wave, short wave, and FM. This FM also activates this switch over here, which is B, or rather C. So we'll see how that works now. So let's have a look at the switching that we have activated and see where we go from here. The way this works, the way I've done this, is I've actually labeled what these switches do. PH is phono and ST for stereo. And I've labeled in the normal position. So when the button is not activated, what are we getting? And the way I've done it here, we're going to look at this when the stereo and the phono are not activated. So we have stereo not depressed, phono not depressed. We have one of the radio channels coming through. Okay? Let's go back to the amplifier. We see what we have here. We have these two channels. These 2 points, this is the phono, and that's also phono. And in the normal position, so phono not depressed, we presume we're listening to radio. We have these two connected. So the signal going into the amplifier comes from here, 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 here. Okay? Down here we have these two connected. So that means that the input to this amplifier is also the same one as that one. So this signal is shorted here, and the signal going in and through the amp is this one that goes this way, and then down here and across, and I can tell you that is the radio signal. The selection of long wave, short wave, and medium wave and FM is done prior to this, but that means that radio is playing through the system. What's happening down here? Well, we're listening to radio, so we have the radio signal coming into the top channel going straight through, as we've seen. We have the same radio signal coming in here, and it actually comes through there, and this part here is shorted. So we have a normal amplification stage here, where the signal from the wiper of the pot goes down here, shorts through there, across here, up there, shorts through there, through a bypass, through a coupling cap, and into the amplification stage. So that means the 2 amps are working simultaneously in this condition. There are a few more switches here that are activated as well in this circumstance. The first one is, or the first 2 are these here. This is part of the stereo selector. If we have stereo not selected, that is closed. So that signal, the one channel, goes there. The other side comes here, goes up here, across here, and meets this one which is the phono selection, which is not selected. So that one is closed and it comes down here. So this signal has done nothing. It just goes across to here. And it now is also this particular signal, the phono is activated. If the phono is activated, that there is shorted. So this is doing nothing at the moment because it goes over here and stops at K3, which, because stereo is not activated, right, it stops right there. Now, what happens if we activate the stereo button? Up here, nothing has changed. That still goes through there. Phono is not activated. Phono is not activated. It's receiving a radio signal. And don't worry about this line over here. This is to the recorder. This goes down here to the tape recorder. So we won't worry about that. But the radio is receiving the amplification section. Both sides are receiving the radio signal as it is. So if we activate stereo while we're playing the radio, a few things change. This one swaps around. So the signal coming in through here, which would normally be the radio signal, which would normally come here and short across to the input of this amp, is suddenly cut short. So this amplifier, this point over here, starts getting this signal here, this signal here. And this signal here is the wiper pot of the reduced or the volume control of a phono, of the signal coming over here. While phono is still not activated, it's still allowing the signal through, right? So it's receiving this signal over here. And what is the signal over here? The signal over here is that channel of the phono, but we've activated stereo, so this one goes across to there. And what we have is this signal, the other channel of the phono, comes in here, through there, through there, through there. So this point over here suddenly becomes the sum of the two stereo sides. So a mono signal from the phono, which goes through there, volume control, out there into the other amp. And that's exactly what we've seen. What we've seen is that you can play radio on one channel, and if you push the stereo button and you have a phono signal, you can hear the phono on the other channel, in other words, the other speaker. So that's how that switching system works. Now we look at what happens when the phono is depressed. What happens now when we activate phono? We want to listen to phono. First thing is, let's fix the switches. That one moves to there. Stereo is not activated, so it stays in its rest position. That one opens. That one, which is also phono, switches to there. We've got two more up here. That one switches that way, and that one switches that way. So what do we have here? We have phono signal comes in here, meets that one, and shorts to that one. So we have mono phono signal. Now this mono phono signal comes to here and does not go through to that section there. It then goes up here. The other signal, which is the same signal, mono phono signal, goes up here. This one comes up here and meets this point. This point is the input to the one side of the amplifier. This other one that goes up here goes to the other input of this amplifier. So what we have at the moment is the phono has been made mono, and it's the same mono signal was being fed to both sides, both inputs of the amplifier sections. There is one further selection here, which is this one here. It was over there, it's been activated, so it shorts across to here. And what we then have is we have this phono signal that came in here, goes through there. You have the volume pot that signal comes down here and goes straight across through the coupling cap into that amp. So we've cleared the way for the phono signal to go through to both sides of the amp in mono. Okay, so that's phono selected, stereo not activated. What happens if we activate the stereo button? There's nothing up here. That stays the same. That stays the same. The stereo button means that this point here goes to there. And because it goes to there, we've now separated this mono system. So we have both of the stereo signals available separately, one to the right channel of the amp and the other one to the left channel of the amp. The other thing that happens is this one, stereo goes that way and does nothing. It's not needed here. So what we then have is this pot is not used in this condition because it's receiving no signal. Its wiper is connected to a dead end. So we have now stereo phono signal coming out of the left channel and the right channel. The only thing that affects them is this balance control between the left and the right channel, where you are effectively, with a minimum resistance of 100K, shorting or reducing the length of the resistance to ground. So you're reducing one side versus the other. So that's how the switching works for the phono and the stereo, and phono without as a separate input to the radio when you have stereo depressed. So what we have is we can hear radio on one channel, phono on the other if you press stereo. You have radio coming on both channels if you have stereo not activated and phono not activated. We have phono mono if phono is activated and stereo is not activated. We have phono stereo if both stereo and phono are activated. Whew. Okay, I think that's about as much of an explanation as anybody will possibly put up with on how this power amplification stage separates to the two channels and how it works. And it's pretty neat. I like the way it's done. The only concern I have is that with all the switching going on, you have fairly long lengths of wire going from the inputs of the amplifier to the switching and to the phono connection and so on. So you could pick up noise. Usually what you want is as short a signal path as possible, so noise is not an issue. However, these are connected with screen cables. Screens are properly shielded cables. They're properly grounded. So the noise has been looked at and carefully eliminated as much as possible. And I believe I haven't heard much noise on that thing at all. Hum I can't hear it. I'll have to try and measure it. And I think I'll look at the voltages and what we're going to do about the power supply and the Selenium rectifier in the next video, because this one's gone on for ages and the paint has dried. All right, bye for now.